Continue with our video on physics. As a JAMB candidate, a science JAMB candidate, you already know how crucial physics is. I don't need to tell you much about it. You already know that for you to gain admission this year, you really need to gain a lot of marks in your physics. So let's quickly go on with our review, Expo questions, review questions on physics. Very, very important. Okay. Number one, I want you to focus. Get your pen and your paper. Avoid every distraction. Anybody distracting you now is your enemy. So run away from any form of distraction as we move on. Okay. Number one, I want you to focus. Which of the following is a derived unit? Which of the following is a derived unit? A. Kilogram. B. Meter. C. Newton. D. Second. Which of the following is a derived unit? Kilogram, meter, Newton, and second. This should be chapter 1 or chapter 2, SS1 work. Chapter 1 or chapter 2 of your work in physics. Okay, the answer is C. The derived unit is Newton. The derived unit is what? Newton. Let me explain. A derived unit is a unit of measurement in the International System of Units, SI. That is what we call SI unit. That is derived from one or more of the 7 basic units. Example of derived units are velocity, that's meter per second, density, force, pressure, energy, and power. So these ones are all derived units. Velocity, density, force, pressure, energy, and power are all derived units. We can derive other units from the independent units. So we have independent units and derived units. I hope you are following. I hope you are learning. We are moving on. Remember, this is not the only video we have done on physics, right? This should be like part 10 or part 11. We have done several videos, and I will encourage you, after you watch this part, to go over and start from part 1. Watch it over and over again. Go to part 2. Watch it over and over again. Go to part 3. Keep watching. Watch all the videos with your pen and your paper. Okay. I said we can derive other units from independent. We can derive other units from independent units. The independent units are called fundamental units or base units. So in physics, we have independent units or base units, fundamental units, and then we have derived units. It is from the fundamental units that will derive the independent units. Okay. Examples of fundamental units are mass, electric current, temperature, amount of substance, mole, and all the rest. Okay. Let's look at question number 2. Remember, the questions we are focusing on are those questions that are not calculation based, right? Those questions that aren't calculation based. Like here, we have 40 questions, but out of the 40 questions, 27 are theoretical questions. You don't need calculator. Only about 13 are calculation based. You can see that both in chemistry and in physics, you have quite a lot of questions that are not calculation based. Let's look at question number 2. If a bar magnet is divided into 2 pieces, which of the following statements is correct? If a bar magnet is divided into 2 pieces, which of the following statement is correct? A. 2 new magnets are created. B. The magnetic field of each separate piece becomes stronger. C. The electric field is created. D. The bar magnet is demagnetized. If a bar magnet is divided into 2 pieces, which of the following statement is correct? A. 2 new magnets is created. B. The magnetic field of each separate piece becomes stronger. C. The electric field is created. D. The bar magnet is demagnetized. Of course, the answer is A. If you get a magnet and break it into 2, the answer will be 2 new magnets will be created. 2 new magnets will be created. Before I give you the explanation, remember that I am giving out free JAMB syllables and free JAMB past questions. Free JAMB syllables, free JAMB past questions. If you need me to give you free JAMB syllables and free JAMB past questions, it's very simple. Just watch this particular video till the end. If you're able to watch this very video till the end, you will qualify to get free JAMB syllables and free JAMB past question. That is for those that watch this very video till the end. Now, back to our explanation. When a bar magnet is cut into two, the newly cut faces will become the new north and south pole of the smaller pieces. Hence, the two cut pieces will have their own north and south poles. Do you understand? Of course, you know that in a bar magnet we have both the north pole and the south pole. That is what basically makes a bar magnet. And when you break it into two, you get two magnets. Okay, let's go to question number 5. Are you still with me? I encourage you to, if you need me to give you all the videos I've done on physics, just let me know. Just tell me to give you the link. We have done more than 10 videos. Past questions, Expo questions, what you should expect. Just tell me to give you the link and I could give them to you. I've also done quite a lot of videos on chemistry, biology, use of English, economics, mathematics, and all the rest. So if you need me to give you a link to all of the videos we have done on those subjects, just comment and tell me to give them to you, and I could also give them to you. Question number 5. A bar magnet is placed near and lying along the axis of a solenoid connected to a galvanometer. A bar magnet is placed near and lying along the axis of a solenoid connected to a galvanometer. The pointer of the galvanometer shows no deflection when... Now, I have an assignment for you. Write it down and tell me in the comment section, what is a galvanometer used for? A galvanometer, what is it used for? That is number 1. Number 2, tell me a barometer. Barometer, B-A-R-O, the meter. A barometer is used for measuring what? These two are 1 and 2nd assignment. Anytime I give an assignment, there is a reason for it. Okay? A bar magnet is placed near and lying along the axis of a solenoid connected to a galvanometer. The pointer of the galvanometer shows no deflection when A, the magnet is moved toward the stationary solenoid. B, there is no relative motion. C, the magnet is moved away from the stationary solenoid. D, the solenoid is moved away from the stationary magnet. Okay, I say a bar magnet is placed near and lying along the axis of a solenoid connected to a galvanometer. The pointer of the galvanometer shows no deflection when the answer is when there is no relative motion. That is B. When there is no relative motion, the galvanometer will show no reflection. That means the meter will not move. No reflective motion because when both the coil and the magnet are stationary, there is no change in the magnetic flux. Hence, no current is induced in the coil. Are you still with me? I hope you are still following. Okay, let's look at question number 6. Remember that I'm going to give you free JAMB syllabus and free JAMB past question at the end of this video. Now, the reason why you need to pay great attention to the videos is that our target in this channel is for you to score 300 and above in your JAMB. If you claim it, pay attention. You will gain admission this year. I want you to claim it. You will be among those that will not be ashamed of your JAMB result. You will be among those that will come back to our channel, to me, with a testimony. You will be one of those that will tell me, invite me for your for your matric, right? You will not only gain admission, but you will gain admission into that particular university that you desire, and they will give you that particular course you desire, not just any kind of course. If you claim it, let me know in the comment section. Why do tires have threads? Why do tires have threads? Okay, if you go to a tire, you know that it's not smooth. They make tires in a way that is rough. Tire, that is tire of a car. Why do tires have treads? A, increase weight of tires. B, increase friction. C, increase its longevity. D, look good. We have treads in tires to increase its friction. To increase its friction. Regular tires have treads which provide your tire with the ability to grip the road, thereby enhancing traction. The tread also helps the vehicle to accelerate and decelerate, as well as to brake reliably. Okay, without those treads, it will be difficult for the tires to move smoothly and to brake when you want to stop. Okay, now let's look at question number 8. The relationship between the coefficient of linear expansion and volumetric expansion y is dash. The relationship between the coefficient linear expansion and the volumetric expansion is dash. You can see the options in the screen, and the answer is 3a. That is 3 times the linear expansion. The A is linear expansion. The relationship between the coefficient of linear expansion and volumetric expansion is 3a. I hope you understand. I hope you pick it. Now, I often tell you, beyond the videos I make, of course, I keep giving you videos on a daily basis, both for the art students and the science students. Beyond these videos I make, I need you on your own to study, right? Burn the midnight candle. There will be time for party. I mean, by the time you present your result to me, your parents, your siblings, your uncles, and you score 320, I mean, you can party, you can go to ShopRite and lick ice cream, right? You can do all the enjoyment, but this time is the time for preparation. This time is the time to study, okay? Ice cream will come later. Let us focus. Which of the following is not a consequence of hydrogen bubbles covering the copper plate of a primary cell? Which of the following is not a consequence of hydrogen bubbles covering the upper plate of a primary cell? A, formation of hydrogen bubbles on the electrode. B, remember they say not. I've always taught you that whenever you are given a question, the first step is what? The first step is to understand the question, understand the instruction of the question, right? You don't just start answering. You need to understand what they are expecting from you. Okay. Which of the following is not a consequence of hydrogen bubbles covering the upper plate of a primary cell? A, formation of hydrogen bubbles on the electrode. B, increase in the resistance of the cell. C, local action. D, polarization. Let me take the question again. Which of the following is not a consequence of hydrogen bubbles covering the upper plate of a primary cell? The answer is local action. Local action is not a consequence, okay? Local action defect caused by the impurities present in zinc rod, okay? Let's look at question number 10. Question number 11. Which of the following liquid is a poor conductor of electricity? Which of the following liquid is a poor conductor of electricity? A, distilled water. B, tap water. C, sea water. D, drinking water. Which of the following is a poor conductor of electricity? A, distilled water. B, tap water. C, sea water. And D, drinking water. The answer is A. Distilled water is not good in conducting electricity. Distilled water is free from electrolytes. You know, by the time they are distilling the water, they remove all the electrolytes that should carry the electricity. Distilled water is free from electrolytes. It does not contain any salt, minerals, and acid, and hence does not have any conducting substance in it. You know, for electricity to move, there has to be a conductor. There has to be either a solid or liquid conductor. In other words, it is a poor conductor of electricity. Are you still here? Are you still following? If the videos I make are helpful to you, I want you to tell me in the comment section, right? knowing that you find the videos I make helpful will encourage me to do more. Sometimes I feel that you people are not following, right? But if you find the videos I make helpful, let me know. Tell me how they are helping you. It will help me to continue giving you more videos. And also, if there are aspects that I have not handled, if there are videos I have not done that will need me to do, if there are areas I have not touched, if there are subjects you think I have not touched that you think will help you to pass, don't hesitate to talk to me about it. I could do those videos for you. Okay? Question number 13. In order to remove the error of parallax when taking measurements, when we were in school and when we enter the lab, we always talk about error due to parallax. Sometimes we call it error due to paragraph, but this is error due to parallax. I'm sure you can see the spelling on the screen. In order to remove the error of parallax when taking measurements with a meter rule, the eye should be focused dash. The eye should be focused when you're taking measurement with a meter rule. Where should the eye be focused? A. Slightly towards the right on the marking. B. Slightly towards the left on the marking. C. Vertically downward on the marking. C. Vertically upward on the marking. The answer is C. When you're taking such measurement, you should look vertically downward on the marking on the mirror, on the ruler. When you get a meter rule, possibly a transparent meter rule, you can see the markings on it. So you should look at it vertically downwards. Okay? Parallax is the apparent shift in the position of an object when viewed from different angles. When using a meter rule to take measurements, parallax can introduce error if the eye is not focused correctly. The minimum parallax, the eye should be focused. To minimize parallax, the eye should be focused vertically downwards on the marking of the meter rule. This means that the eye should be directly above the point being measured. Are you following? Looking straight down into the markings. By aligning the eye vertically with the markings, any potential parallax error is reduced, resulting in a more accurate measurement. Remember that if you watch this particular video to the end, you will qualify to receive free JAMB syllabus and free JAMB past questions. You watch this video to the end, you will qualify to receive free JAMB syllabus and free JAMB past question. Look at question number 14. Question number 14. An athlete standing waist deep in a swimming pool appears to have short legs because of the light dash. An athlete, by the time you pass your exam very well, you can actually go to a swimming pool and enjoy. And you see that when you enter a swimming pool, just look at this question. An athlete standing waist deep in a swimming pool appear to have short legs because of the light dash. When you're looking at the legs of a person in a swimming pool, it appears as though the legs are short. The reason is it light diffraction, or B, light refraction, or C, light reflection, or D, light interference. Which one is the answer? Is it diffraction, refraction, reflection, and interference? I will not answer this question. I want you to tell me the answer in the comment. Tell me the answer of question number 14. And in the next video, we will continue from question number 14, where I will tell you the accurate answer, but I want you to try it. There's an assignment for you in this video. The assignment is for you to come under this video and tell me the difference. Just give me the definition of diffraction, refraction, reflection, and interference. You can see them on the screen, right? Give me the definition of these words on the screen. There are physics words that I'm sure you have met before. Diffraction, refraction, reflection, and interference. Please don't jump and pass the assignment. Whenever I give an assignment, I already know something you don't know about the coming examination. So go over and give me the answer. And in the next video, in the next class, we will continue from question number 14. For you to receive the free JAMB syllabus and free JAMB past question, I promise, just do 4 things. Number 1 is compulsory. Number 1, join our YouTube channel. Just click on join. It's an investment that you need to make. When you join our YouTube channel, you'll be able to talk to me directly. You'll be able to ask your questions. You'll be able to receive clarifications, right? So join others. We're already many in the group. Just click on join and follow the prompts and join immediately. Do that now. Number 2, like this video. Just click on like. Number 3, share this video. Click on share. Sharing is very important. Click on share. Our people will say there's love in sharing. So click on share. Share this video here on YouTube. Click on share again. Copy the link. Share it on Facebook. Share it on YouTube, on Telegram groups, on WhatsApp groups. Share it to your classmates, your friends. Everybody writing JAMB should have the link. Then finally, subscribe to our YouTube channel. When you subscribe, turn on the notification bell. So join our channel, Noble Tutorials. Like this video, share this particular video, then subscribe to our YouTube channel to receive those materials. Once you subscribe, come under the comment of this video and type I have subscribed. Do what? Type I have subscribed. Once I see you type I have subscribed, I'm going to chat you up and send to you all those materials. I'm leaving a very important video for you on the screen. Click on it and watch now.